Looking at this problem, we have our radical, and we want our radical, the radical x plus 3, x plus 3, this thing right here, what do we want that to start equaling? Remember when we started this, did we want a 1 in here?
No.
Yeah, we want our first thing to be 0, the first perfect square. So we want the x plus 3, the thing inside, we want it to equal 0. What else do we want it to equal? Hey, let me pause for a minute. I see some of you tuning out. Like the first problem was really easy. Let's go back to that one real quick. Let's go back to the good old days. There's our first problem. Very easy, right? How many thought the first one was easy? Okay, don't get so like sold that you don't have to pay attention anymore. This is where most students get lost, is the second problem. Okay? It's like going out in the woods with your friends and hanging out. You're like, dude, let's go out. We go out and play. We like cruise out in the woods. You like run out to the woods. Hey, it was easy to get here. Then you got to go home. You're like, I don't know how to get home. Because you didn't pay attention, man. You pay attention. You know how to get back to the graph, right? Don't want to get lost. Jeez. Yeah, don't go out in the woods alone either. That's kind of creepy. Okay? So we got x plus 3 equals 0. Tell your neighbor, what else do we want x plus 3 to equal? The thing in here, what else do we want it to become? Okay, heard some of you say it. What else do we want x plus 3 to be?
1.
We want it to be 1. What else do we want x plus 3 to be?
2.
Do we want it to be 2?
No.
Remember this, if we say x plus 3 equals 0, okay, if we get a 0 inside here, that would mean the square root of 0, which is good. And if we get x plus 3 equal to 1, that would mean the square root of 1. Savannah. That's good. Pay attention. Like, look here, though.
Oh, sorry.
Okay? If we get x plus 3 equal to 1, what else do we want x plus 3 to equal? 4. We want it to be perfect squares. What else do we want x plus 3 to equal?
9.
We want it to equal 9. Okay? Right? Okay, now the problem is, what makes x plus 3 equal 0? Do we put 0 right here?
No, -3.
No, we have to put -3.
Oh, yeah.
So if x plus 3 equals 0, x equals -3. Right? You just solve that. You say x plus 3 equals 0. So if you need to, have a piece of scratch paper. Subtract 3 on both sides, x equals -3. Have a piece of scratch paper there if you need it. Angel.
So would that be like your vertex, -3 and 0?
-3 and the root of 0 is 0. That would be our vertex, yeah. Good. Hey, and if we put x plus 3 equals 1, for those of you that need to scratch that out, okay, it's not equal to -1, +1. Okay, we subtract 3 and subtract 3, we get x equals? -2. So in order for this to be true, x has to equal -2. That's what makes that 1. And the square root of 1 is?
1.
1. Tell your neighbor what makes x plus 3 equal 4. Okay, now some of you are thinking too hard. You have like smoke rolling out of your ears and stuff. Look, just write it out. Subtract 3. X has to be 1. Now those of you go, it's so easy when we do it in class. Well, it's because you guys show work, right? X has to equal 1. So when x is 1, we get root of 4, which is 2. When x plus 3, to make that equal 9, show your work. Subtract 3, x has to be 6. Yeah, so x is 6. So when x is 6, we get root 9, and root 9 is 3.
You're saying right.
Okay? And there are our points.
But we don't go negative, right?
Yeah, we don't go negative because we can't take the root of a negative.
Well, no.
Hey, go ahead.
Well, I wonder how you got, when the square root of 9 in the last column that you wrote, how'd you get 6 points?
I didn't. I said to get, remember, the thing under the radical isn't 9, it's x plus 3. So we want it to become 9. And that's what we were doing over here. We're saying the thing under the root, the x plus 3, has to become 9. And so we do all the math, and we say, in order for that to be true, this has to be a 6. 6 plus 3 is 9. That gives us that perfect radical.
That's so radical.
We'll do some more. We'll keep doing them, okay?
I so failed right there.
I think that is radical. Totally radical. All right. Hey, let's graph those points. We get negative 3, 0. Negative 2, 1.
What? Nothing. I heard my name. It doesn't involve me if I heard my name.
1, 2. And 6. 3. Check it out.
Wouldn't the Y be negative 3?
That's way radical. What's that?
Wouldn't the Y, the range, be negative 3?
It could be. Yes? Oh, good question. Do we put an arrow over here?
No. No. It stops.
Yeah, it stops. We can't go any further this way, right? It starts here. So that's a great question. Some people put arrows there, and that's not right. The graph isn't going any further this way. It doesn't keep going on the x. It starts right there, and it keeps going this way forever. Okay? So that brings us back to our domain and range, our x and our y. Okay? Where does our graph start at for x? Negative 3.
Oh.
Where does it start at on the y-axis?
0.
I was 0. Went out.
Okay, so if we follow our y up,
Is it 2?
starts right here, right? So think of your y, this pencil, or this pencil right here is y equals negative 10. Stay with me. This negative 9, negative 8, negative 5, and we are now at y equals 0. And now we're at y equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this pencil, that's that line. This is the line y equals 0, happens to be the x-axis. Okay? So our graph on the y-axis starts at y equals 0. It starts right here when the line is here. Starts at 0, and then from there, is my pencil going up or down? Which way is the graph going?
Up.
It's going up. So that means greater than. And since it exists on 0, it's equal to as well. And the same thing with y. So those of you confused, or for x, excuse me, those of you confused, this is x equals negative 10, and we're cruising this way, negative 9, negative 8, negative 7, negative 6, negative 5, and we get to here, and that's x equals negative 3. Okay? It starts there, and it keeps going this way, which means it's getting greater. It's getting bigger. So it starts at negative 3 and gets bigger. And remember where we saw that in our equation. Our original equation was y equals the root of x plus 3.
Why does it get greater?
Why does it get greater? Because it starts here and goes towards the bigger values of x. If it went this way, then it'd go less. Yep. Okay, we start at y equals the root of x plus 3. What are we adding to the outside of this? Remember me doing this in the last problem?
0.
0. What are we subtracting inside here?
3.
0.
Okay, better yet, this kind of goes to Savannah's question. Remember that? She had a good question. She said, why did you use minus in the last problem? Why didn't you use plus? Well, this right here, what makes that equal 0?
Negative 3.
Everyone agree it's negative 3?
Yeah.
X plus 3 equals 0 at
Negative 3.
negative 3. So x equals negative 3. Whatever makes this equal 0, that's that value. And the thing you're adding to the outside, that's that value. Okay? It's whatever makes the inside 0. You guys, this is a pattern you see all throughout math. Okay? And when you get to advanced algebra, you're doing like 12 or 13 different types of graphs. in almost all of those, you see this little pattern. Whatever you're adding or subtracting with the x, that's going to determine how far you shift this way. And whatever you take away or take and put on at the very end of your equation, your constant, that determines this. Not always, but that's called a vertex of our graph. Okay, everyone rate themselves 1 to 5 right now. Okay. You don't have to give yourself like 7 to make me feel good. You can just. Some of you giving yourself 8. That's good. All right. Hey, if you don't. Hey, any questions before we move on? We're gonna keep trying some of these. We'll get them. Kimmy? How did I get 0 for y for the range? Right here? It's this coordinate right here. -3, 0, our starting point. So this is your x, that's your y.
And y is greater than 0 because the graph is going right.
Yep, because it starts right here, so we're going our y-axis, these little lines, that's y equals 9, 8, 7, 6, 5, 4, 3, 2, 1, y equals 0 is that line right there. I know it seems confusing because that's the x-axis, but if you kind of separate, really, you guys did this when you were really young. You had number lines, and you put 0 there. How many remember number lines like that? Okay, they're just number lines, right? Here's 0, here's 1, here's 2. All an x-y axis are 2 number lines lying on top of each other. There's your x-axis. Your x-axis just goes this way, and you have 0 there. Okay? Make sense? All right, let's try this next one. Number 2. Before you try it, just based on what we've talked about domain and range, I want you guys to predict what the domain is and what the range is going to be. So that means you're going to have to step out of your comfort zone, some of you, and actually write something down before you do the graph. Write down what you think the domain and range will be. Write it in pencil, that way you can change it if you need to. Okay? Let's see how we did here. Let's recall, what do we want x minus 4 to equal?
0.
0. We want it to equal 0.
Yes.
We want it to equal what else?
1.
X minus 4 to equal 1. What else do we want it to equal?
4.
4. And what else?
9.
9. All right. Oops. Minus 4 equal 9. All right. Any questions from there? Guys, we go really slow today because I really want you to get this. This is easy if we can stick with it. Okay? Ask good questions. So, x minus 4 equals 0. What makes x minus 4 equal 0? That's what we want it to equal first. Savannah?
This many.
4. Correctamundo. X equals 4 here. Okay, which means we put 4 right there and we take the root of 0 to get
0.
0. Okay? And then we can plot that point. 4, 0. 1, 2, 3, 4, 0. Some pretty good counting.
Thanks.
All right? What makes x minus 4 equal 1?
5.
We add 4 and add 4. We get x equals 5. X equals 5. Okay? So when x is 5, we get 1 inside. Root of 1 is?
1.
1. All right, so we now have another point 5, 1. You guys notice that this point keeps getting only 1 away every time?
Yeah, I know.
Just giving you a hint. There, we got plus 4 and plus 4. What makes x minus 4 equal 4?
8.
Has to be 8. X equals 8. When x is 8, we get the root of 4, which is 2. 8, 2. What makes x minus 4 equal 9? Well, we add 4 and we add 4 and we get
13.
13. X equals 13. Okay, 13. Is that going to fit on our graph? No. We get 3, so we have 8, 2, which is right here, and then the other one doesn't fit, so we get that. And an arrow on that end. Thank you. There we go. How many got that far?
I'm all done.
Cool. Yeah, I see Ashley and Ashley and Bree throwing math symbols at each other. Well done. Better than gang symbols. It's a math symbol.
3, 4.
I saw you. It was good. It's because I won't let you text in class anymore. That's all. All right. You got it? Ashley, you got it? You sure? McKenna, does she have it? Savannah, does she have it?
Yes.
See, Savannah, at least look. McKenna, you didn't even look. You just said yes. You're like, oh, that was nice. Okay. So what's the domain? Well, you guys predicted the domain. That's 4, 0. X is greater than or equal to
0.
4. Y is greater than or equal to
Ditto.
0. How many put that before you even started? Hey.
Well, for the x is greater than 4, I accidentally put 0, so would that be wrong?
That means nothing.
Yeah. That'd be like you saying, hey, McCoy, you owe me $4 and I give you $0. Would that be okay?
Yes,
No.
please.
No. All right.
I'll give you $2.
Hey, so Savannah, let's go back to your question a long time ago. You said, why did you put minus in there? Notice when that says minus, which way does our graph shift? You go right or left?
Oh, right.
It goes,
Right. Yeah, right.
it goes this way, right? Hey, when that was plus, going back to the previous problem, when that was plus, which way did our graph shift?
No, wait, I would left. Yeah.
Come on, it shifted the other way, right? It's kind of backwards. That says x plus 3, we shifted that way. This one says x minus 4, and we shift that way. It's always opposite. Remember, it's what the way we figure out our vertex and our domain is what makes this thing 0. X minus 4 equals 0 when x is 4. And what are we adding on the outside? 0, and that's where we get that. Hopefully this is getting really boring and it's because it's good. Like you understand it, not just because it's boring.
One
I
out.
get it. I get it.
All right.
One out.
Questions?
I was going to be the next one, but I didn't understand.
Okay, moving on. I want you to try number 3. Tell your neighbor, actually, before you tell your neighbor, I want you to write down what the domain and range are on number 3. Don't tell your neighbor that. Write it down first. What are the domain and range going to be? Be careful.
0.
Hey, remember this one? Look at this one. This one's different now. We have x, and we have the root of x, and we have minus 5. Yeah, you want to try to make the radical 0. Okay, well, what do we have to make x equal if the radical is going to be 0?
5.
5.
No.
Yeah, 5's on the outside. Well done. Yeah, we've got to make,
Right?
yeah, x is 0. Yeah, we just put 0 in for x. Okay? Hey, and the root of 0 is 0. So I'm going to write that above it. 0 minus 5 is?
5. Negative 5.
Negative 5.
Yeah, I think I was right.
So when that number's on the outside, it messes us up a little different, right?
Oh.
Yeah,
Hey.
I get it now.
Okay.
Hey, pause for a minute. Notice our starting point. That's our starting point. 1, 2, 3, 4, 5. It's way down here. Our graph is now moved downward. Okay? It's not shifting this way because there's nothing in there with x. It's shifting down. Right, man?
So when y.
Try the number 4 and 1 on the back. Okay?
Okay, is that it?
Yep.
Okay.
Okay. Hey, what else do we want to make our root equal? 1. We put 1 in. So we get 1. Root of 1 is 1. 1 minus 5 is? Negative 4. Maddie, what else do we want to make our root equal? What else do we want to make the root equal? 4, yeah. The root of 4 is? 2. 2 minus 5 is? Negative 3, yeah. You know, I think next year I need to make these boxes bigger.
What?
What else do we want to make the root equal? 9. The root of 9 is?
3.
3 minus 5 is?
2. Negative 2.
Negative 2. Way to sing it, yes.
There's an opera every time you answer. Oh, my Irish. We'll get over yourself. We don't care.
Whoops.
You're
That one's the wrong spot. Ignore that point.
Mr. McCoy, but didn't really put that high on this weekend.
All right, how many of you made the mistake at the beginning? You dealt with the 5 there. Okay? Did we get it now? Okay, what's our vertex? Tell your neighbor the coordinates of your vertex. Okay? What do we got? 0, -5. Okay? Here's the coordinates of our vertex. Now use those coordinates in your equation to fill in your domain and range. X and Y.
It's gonna be loud.
They are, yeah.
Lordy. How rude.
Okay, so on the x-axis, when we're going this way, where do we start? At 0. And then are we getting bigger or smaller? Yeah, we're growing this way, right? So it's x is greater than or equal to 0. How about the y-axis? Start at -5 and go up. So that's greater than or equal to -5.
So proud of you guys.
Okay, and remember over here, you're looking at y is equal to the root of x minus 5. What's inside that root symbol with the x?
0.
Yeah, we're subtracting nothing, right? That's where that 0 comes from. And what's on the outside? The -5. That's where that came from. How many are seeing the pattern? Okay, questions on it? Okay, you have to do number 4 tonight. I also want you to take a look right now at number 5 on the back. And based on what we just said about the vertex, I want you to tell your neighbor where the vertex is for this graph.
Yeah. Do we actually just solve it or just?
Right now, just... Okay, can I get a volunteer? Where's the vertex? You look like really impatient. You got it?
Oh, what?
The vertex?
No. Well, no.
What do you think it is? What do you think it is? Teddy, what do you got? 0, -2. It's not 0. No. Ashley? What's that? That's really close. It's almost 4, -2. What'd you say? -4. -2. -4. It's what makes this 0, right? It's our first point. We're trying to make that equal 0. Subtract 4. Subtract 4. X equals -4. So -4 is our first point. And the outside is our -2. As I've really tried to work that in today, making sure that we can start seeing that. And notice how I extended my root. I'm going to put a little ending point right there. That's silliness. I know. So when I put in -4, I get 0. Root 0 minus 2 is -2. And that means my vertex is at -4, -2. What else do we want x equal on this one? Burke, what's up? No, you don't. You want it to be 1. Right? So when we solve, we set it equal to 1, we subtract 4, we get -3. So x equals -3. That means you're going to put in -3 here, and that's going to give you root 1 there. That makes that x plus 4 equal that 1. We subtract 2. Root of 1 minus 2 is? -1. So our next one is -3, -1. Kimmy? Why don't you do the plus 4? Because you're making this, you're trying to make the inside of the radical equal 0. So you've done that here. You've said, okay, I want this thing in here to become 0. So to make this change to 0, I'm going to set it equal to 0 and solve. So when I put negative 4 in, negative 4 plus 4 is 0. So I put negative 4 in for x, add 4, I get root 0. So I do add 4. I'm adding 4 to negative 4. Okay?
Do number 6.
Yeah, you guys need to do you have to finish 5 and 6 tonight, as well as number 4. Okay?
4.
Very good. We'll go through the rest of it tomorrow. Woo!